hopefully the camera can see me there a bit. Hey, what's up guys, how's it going? So I want to do something a little special today for these 5 videos. What I'm going to do is I'm going to go over 5 different physics problems, some of my favorite problems that I would like to show you guys, and these are the ones that I do know how to do, that I still remember. I mean, I have a book that I'm going to follow along, but yeah, these are things that I can maybe kind of understand and explain to you guys. So let's start on the first physics problem. So the first one is basically, let's say you have a car. And we're got to a good start. Let's see if there's another this really quick. Oh, it's a little, at least it's kind of, I mean, I wish I had the black marker, but I don't even know what that one is. Oh, I found the logo. There we go. Let's try this one. Nice, see, there we go. Okay, so it says, so the first problem says that a car, so you have a car, weighs 1,500 newtons. That's kind of hard to see, but it's 1,500 newtons. And so it's being pulled by a truck. So you know, if you imagine like on the freeway, you know, some guy gets stranded. So now, yeah, this truck has triangle wheels. And the tension here, this tension is 2,500 newton, and there's a 200 newton friction force. So then if it starts from rest, so at rest they want us to find, actually let me do this. Let's make sure. So this, what is the speed after 5 seconds? Sorry, 6 seconds. Let's make sure this thing is kind of, yeah. Okay, cool. So essentially, we have a car that's 1,500 newtons. It's being pulled by a force on tension that's 2,500 newtons. Then you have a 200 pound-newton friction force that's opposing the direction of the car. So essentially, at rest, what ends up this? If it starts from nothing, 0 essentially, that's basically what the rest means. What would the speed be after 5 seconds from this interaction? So what we do first is we do a sum of forces. This is basically like what you usually do, you know, like for any physics problem. So first let's find this. So always remember that the sum of the forces in either direction have to equal 0 to maintain the equilibrium balance. So let's look at all, and just in case, where is this coming? X is coming from? We're looking from an x-y plane. So we gotta find out all the x's, the forces, and then make it so that they all equal 0. So what do we have in the x? Well, first we have a 200 newton force, if I'm corrected. Yeah, we do. Yeah. Well, actually, you know what? This thing does it kind of weird. Okay, well, let's do the forces here. So assuming this is all going laterally, you have a 200 newton force going this way. Then this way you have a tension force. This one's kind of weird, maybe, because yeah, that's. Well, they do it kind of weird here. So essentially, I guess how they do it is like this. They say, okay, so let's pretend this dot is the car. So you have a normal force, I guess, that has to balance the gravity. So let's see. So this is this I get what's going on. But then it has the friction and then the tension. I mean, I guess that makes sense. I was thinking differently, but no, I guess the book does something weird. Oh well. Well, I mean, it makes sense, but I was thinking it kind of differently. Well, anyway, essentially what's going on is that you have gravity going down that has to be balanced by a normal force, then you have a friction force that has to be balanced by a tension force, and so you have T minus F would equal 0 if we do the force sum of forces in the x direction. Then you have a normal minus the gravity, which will also be 0 if you do the sum of forces in the y. Okay, so I guess with that, how do we find the speed though? Or like, how does this kind of help us? Well, you can kind of see now like what kind of forces are interacting with one another and why each of these would affect certain stuff. I mean, for me, I'm glad I'm doing this because it's helping me remember some of the stuff. It's been a little bit since. I mean, for me, it's still fresh in my mind. Oh, that's not good. Never do that. So, for me, it helps me kind of refresh my memory on my physics stuff. Okay, so once we have that, we do the F equals ma. So remember this guy, the fundamental equation of physics, I would call it. So you're wondering, okay, so how do we use this to calculate what we need to do here? Well, first we need to find the acceleration because we're gonna need to find the speed. So you're probably wondering, well, what's the mass and the force? Well, first let's rearrange this so that A is equal to m. No, oops, sorry, I was looking at it differently. F over m. Now, this mass here, you already know what this is. The mass, this is just the mass of the car, which is 1500. Wait, what the hell is this? This is kilograms. It's Newton, right? Oh, sorry. This is kilograms. I'm sorry. I'm stuck with the Newton part. Okay, so yeah, 1500 kilograms. Now, what is the force? Okay, oh, okay, now this makes sense. So now this is where this comes in because now you have a difference of forces. So first you have a tension force here. And that's going to be, wait, what the heck? No, I'm right, yeah. So it's going to be a 2500. No, it's because there's another problem. It's kind of for some reason it counterbalances with the other one, so weird. So right here you have two x forces because we're only interested in the x component of the speed, not because we're not going up, we're not rocking. Okay, so you have this force, which is a tension, and then you have the friction force, which is 200 Newton. So then once you do the math here, you get 1.53 meters per second squared. And just to clarify, acceleration is always meters per second squared. Lots of badass. And then v is always meters per second in the metric system. When you do physics, you realize that almost everything you do is always in the metric system, because essentially every other country in the world uses the metric system, except us, because I guess we're cool. No, I'm playing. Well, it's worse for us because then we have to learn two types of measurement systems, not just one like in other countries. So anyway, so once we have that, then we use what's called the kinematics. So this is basically the study you learn in the first few chapters, the kinematics of velocity, acceleration. So without going much into detail, I mean, these formulas are basically like compound. These are formulas that you learn in the first, like I said, the first few chapters. These should be like kind of like all I remember. Or there's usually every book has like a reference guide, and you just look at it and go, oh, this helps us find speed. So the equation here that I guess would help us out would be bt of x, and I'll explain what this is equal to v naught of x plus axt. Okay, so this is really confusing. So usually what I like to do, do this. I like to use VF and then VI. So VF, that just means the means final. So it means the final speed or final velocity, whatever that I'm trying to find, is equal to the VI, which is the initial velocity from where the thing starts, and then plus acceleration times time. Well, we have acceleration, we just found it here. We have time, which was given to us here at 5 seconds. And then you might think, well, I don't know what VI is. Well, it tells you here at rest. All that this means at rest, it means that since it starts at nothing, this thing would be 0. So essentially, you can find your velocity. You have everything that you need. So this would be Vf is equal to 0 plus 1.53 times 5. So your Vf is just equal to 7.7 meters per second. So overall, I mean, I kind of started iffy because I was trying to kind of do like back and forth what's going on, and I was trying to explain from what I can remember what's going on. So essentially, this does help because you can kind of see, okay, well, I mean, you don't really need these in retrospect. You just need these two forces, because once you get the acceleration from here, then you can just use the kinematics to find. So this is still like initially this is like beginner physics essentially still. So I mean, hopefully you guys understand that. I'll do 4 more videos, so hopefully as it is going, I'll be more clear on what I'm trying to do. So hopefully you guys enjoyed that, and we'll see you guys in the next video.